Okay guys, welcome back once more to another video in this YouTube channel. Uh, in this period, basically be using my phone and little typing skills that I have to produce content. So we are going to be solving this very exciting question that came in Public Works Meng 2023. So here is a question. I just copied the question and pasted here so that it can ease our process. So it reads, a light ray is sent towards the x-axis from this point with inclination alpha. Let us assume tan alpha is 3. Then the equation of the line containing the reflected ray from the x-axis is, we have those options. Okay, so we have a light ray that is being sent towards the x-axis from this point. They have given us the angle of inclination and they have given us that tan alpha is equal to 3. So now, first of all, I cannot really draw using text. Okay, so to draw, I think we just have to snap a picture. Okay, I just hope it is still recording. So I've snapped a picture, then I'm just kind of going to draw the diagram. All right, so I'll just draw my xy plane. All right, I just have to draw my xy plane. Then I locate my points when x is equal to -2, that is -2, y is equal to 3. So kind of this is a point here. All right, that's a point P. So the ray of light is sent from this point towards the x-axis. So it could be coming like this, right? It could actually be either coming this way, or it could be coming this way, passing through that point in this direction, or it could be coming this way, passing through that point in this direction. All right. So it all depends now on, all right, what is the gradient of that line. Remember that if a line is in this direction, then the gradient is positive, but if it is in this direction, then the gradient is negative. So by definition, the tangent of the angle that the line makes with the x-axis is the gradient of the line. All right, so let me just give you guys that little proof. All right, let me give you guys that little proof then before we come back. So imagine that I have a line, for example. This is my line. All right, this is my line, for example. So I have this line, for example. Then this line is passing through a certain point. Here's the x coordinate of the point, and here's the y coordinate of the point. So this point is xy. I'm writing with my phone here. Okay, then this is the origin 0 0. Okay, um let me just write it. That's the origin 0 0. Now this line is making an angle of alpha, for example, with the horizontal, that is with the x-axis. Okay, then if I ask you to find the gradient of this line, if I ask you to find the gradient of this line, you tell me that the gradient is equal to change in y. It means because we already have 2 points on the line. We have the point xy and we have the point 0 0. So change in y is y minus 0. Change in x is x minus 0. And this is going to give us y divided by x. All right. Now, if I ask you to find the tangent of that angle alpha, you tell me that tan alpha is equal to opposite. This is a right angle triangle. Okay, so opposite to that alpha is y, and the adjacent to the alpha is x. So you see that the tangent of the angle, the tangent of the angle that the line makes with the x-axis is a gradient of the line, because y over x is tan alpha and y over x is still the gradient. So by definition, the tangent of the angle made with the line with the x-axis is the gradient of that line. Okay, so I'm going to, I don't know, I'm just going to send this thing to my chat. Then I'm going to, we take another photo and then we solve the problem. Okay, now let us solve our given problem. So I draw back my x and y axis. So this is x, this is y. I locate my point. Maybe this is -2 and this is 3, because my line is passing through the point -2 3. That is my point. Now, like I said, the line could be going towards the x-axis in this direction. It is still incident on the x-axis, or it could be going towards the x-axis in this direction. It is still incident on the x-axis. But what is going to give us a clue on the direction is a gradient. All right, so since we have that, we actually have that the tangent of the angle that the line makes to the x-axis is equal to 3, and since the tangent of the angle is a gradient and theory is positive, it therefore means that my line is going to be going in this direction. Okay, so my line is going to be going in this direction. So this is my line. It's going to get the x-axis at a certain point here. I don't know the point. That is what we call the intercept on the x-axis, and this is going to be the intercept. This is the intercept on the y-axis, and this is going to be, that c is the intercept on the y-axis, and this is going to be the intercept on the x-axis. Okay, now since my, because this is actually going to be alpha, all right, then the ray of light is going to be reflected. So normally it is incident towards the x-axis like this, and then now this is a reflected ray. So if I extend a line, this line that I'm drawing here is a line that contains the reflected ray, all right, while this first line is a line that contains the incident ray. All right, so that is it. Now we know Snell's law. It says that at the point of incidence, in fact, the angle of incidence is always equal to the angle of reflection. So it means that if I have alpha on this left hand side, then this other little angle here is also alpha, because that is the angle of reflection, the angle that the reflected ray makes with the angle that the reflected ray makes with the normal. In this case, the normal is the x-axis. All right, so that's my angle of reflection that other way. Now what will I do to get the equation of this new line L1? I will first of all need to find the equation of this line L. All right, if I find the equation of this line L, then it will be easy for me to get the equation of L1. So this diagram is already dated. I'm going to send to my chart, then I continue back again. So you just have to be following me step by step.